Hello everyone, we're back again at another video. In this video, I will present and show the solution of problem 9.114, still from the Mechanics of Materials, 4th edition by Beer, Johnston, and D. Wolf, presented by yours truly, ANNIKA Lirazan. So, the problem 9.114 states that use the moment area method to solve the following problem. For the prismatic beam and loading shown, determine A, the slope at end A, and B, the deflection at the center C of the beam. So I will start off with this problem in an analysis by constructing a free body diagram, a shear, and a bending moment diagram. So it's already constructed in this slide. So from our free body diagram of the beam, we determine the reactions. To find the reactions of this particular beam, we sum the forces equal to 0. So, RA plus RE plus P minus 2P is equal to 0. So, RA plus RE is equal to P. Then, in order to find RA and RE, we take the summation of moment A equal to 0. So, we get P times L over 4 plus P times 3L over 4 minus PL over 2 minus REL is equal to 0. So we can obtain the values of RA and RE, which are both equal to P over 2. So in our diagram, the origin is at A. Since the beam and its loading are symmetric with respect to the midpoint C, the tangent at C is horizontal and is used as the reference tangent. Referring to the sketch, we observed that since theta C is equal to 0, now we can write that negative theta C plus theta A is equal to A over EL. And theta A minus theta C is equal to 1 over EL multiplied by quantity 1/2 times L over 2 times P L over 8. And then we can obtain the slope at end A by using the first moment area theorem. We write that the slope at end A is equal to theta A is equal to PL squared over 32 EL. So that's the answer for slope at end A. Next, for the deflection, first we apply the second moment area theorem. So our first equation, YA minus YC is equal to A over EL times N is equal to 1 over EL multiplied by A1 and 1 plus A1 and 1. So by solving for A2 and A1, A2 is equal to A1 is equal to 1/2 times L over 4 times PL over 8. Then let's solve for x1. x1 is 2/3 times L over 4, and then n1 is equal to L over 6, and x2 is equal to L over 4 plus 1/3 multiplied by L over 4. Then the value for x2 would be L over 3. So using this value, we plug it in into the first equation. So YA minus YC is equal to 1 over L multiplied by quantity PL over 64 times L over 6 plus PL over 64 times L over 3. So note that these values I already I plugged it in using the values from the previous slide. So again, YA is 0, so 0 minus YC is equal to PL squared over 192 EL multiplied by quantity L plus L over 2. So our deflection is YC is equal to negative PL cubed over 128 EL. Or we can write it as YC is equal to PL cubed over 128 EL downward. So the negative sign indicates a downward direction. So this is the final answer for the deflection at the center C of the beam. And that ends this presentation. I hope you learned from this problem, and we can apply this knowledge to solving other problems using moment area method. Thank you.